Good morning, students. Today we are going to see one of the important point from the pre-formulation studies, in which we are going to discuss regarding the chemical properties of a drug molecule and what role they have in the pre-formulation as well as the development of a dosage form. So today we are going to discuss regarding the three main chemical properties of a drug molecule, mainly firstly the hydrolysis, then oxidation and reduction, and lastly we are going to discuss regarding the racemisation. So before we proceed further, I would like you students to ask, have you heard about these words, that is hydrolysis, then oxidation, reduction, racemisation? Have
Yes,
you
sir.
heard? Okay. So where you have heard these words? Where you have heard these words? Hello. सर मी लेक्चरमध्ये तुम्हाला बोल.
In chemistry.
In chemistry you have heard this. Okay. So it means what? It is related to the chemical properties. In the earlier discussions regarding the pre-formulation studies, we have seen various physical properties. So today we are going to mainly focus on the chemical properties. Now let's see these chemical properties one by one in detail today. Firstly, let me go to the first point which we are going to discuss, that is the hydrolysis. So what do you mean by hydrolysis? Whether water is added or whether water is released from the reaction when hydrolysis takes place?
Water is added.
Water is added when hydrolysis takes place. Everyone agree with this? See, we are not going to go and see the exact mechanism how the hydrolysis takes place. Okay. So the point which we should understand for today's discussion is the drug molecule will interact with the water. So when we talk about hydrolysis, okay, the water molecule, that is H2O, it will interact with your API, or the, we can say it is drug. Okay. Now when the water molecule interact with the drug, and if it is leading to hydrolysis, it means what will happen? It will break down the product. Now there are certain kind of compounds which are susceptible to the hydrolytic process. Now susceptible means they are the more prone to undergo hydrolysis when they come in contact with water. And what are the examples of such a compounds we can say? For example, esters, then we have substituted amines, then lactones and lactams. An example includes the drugs from the category of anesthetics. Okay, because when you talk about the chemical structure of this anesthetic, mainly they are amides and esters. Okay, then we have antibiotics. Okay, so these antibiotics, they belong to the class of beta lactam. We have a special class of antibiotics, that is beta lactam antibiotics. Then vitamins, then we have barbiturates. So under barbiturates we have certain drugs such as phenobarbital, cecobarbitone, and so on. So I hope you people have understood this point, at least the basic introductory part, that what do you mean by hydrolysis and how it will lead to the breakdown of the product. Fine? इथपर्यंत क्लियर आहे सगळ्यांना?
Yes, sir.
So in a hydrolysis, what will happen? There will be interaction of water with the drug, okay, which can lead to the breakdown of your product. Now, the first point under hydrolysis which we are going to discuss is regarding the ester hydrolysis. Now, under ester hydrolysis, the first example which we are going to see is acid plus alcohol, in which there is a we have which involves a rupture of a covalent linkage between a carbon atom and an oxygen. So when we have acids and alcohol in one place, that time what will happen? There will be a rupture of the covalent linkage which is present between the carbon atom and an oxygen. Then the catalysts such as the polar nature of the mineral acids, alkalis, or certain enzymes. And when we talk about certain enzymes, for example, the enzymes which are capable of supplying H++ or hydroxy ions, that is OH minus ions. Now, the kinetic studies of one of the drug, that is aspirin, after hydrolysis shows that when it was carried out in buffer solution, the final observation was the aspirin is more stable at 2.5 and the pH between at a pH 5 to 7, and the degradation is pH dependent, is pH independent, and above pH 10 the stability decrease with increase in the pH. Now from this, what do we come to know? That what we have studied is, for example, here we are talking about a drug that is aspirin. What was studied? We have seen that when you are going to put this aspirin into a water, okay, especially when you prepare a buffer solution, the solvent which we use is water, okay. So you have a buffer solution. So here ester hydrolysis we are talking about, okay. So when the ester comes in contact with the water, here we have seen the example of aspirin. So the final observation we can say it was that this aspirin was more stable at a particular pH, and the pH was 2.4, and at pH 5 to 7 also we can say it was stable. Now the degradation for aspirin, which is an ester molecule, it is pH independent, and above the pH 10 the stability decrease as there is increase in the pH. We can say it as it is moving towards the more basic things, it will be now as it is as the pH is moving toward the more basic part, you will find that the stability of the aspirin is decreased. Now moving further, whenever we talk about the various factors which has to be considered when we are studying hydrolysis, it includes firstly the pH, okay, then the type of solvent, and the properties of the solvent, such as solvent which are having lower dielectric constant. Examples are of the solvent, that is ethanol, then we have glycols, mannitol, etc. Then the complexation. So when we talk about the complexation, the steric or the polar effect we have to study. Example of the drugs for example caffeine and benzocaine, which has the electronic influence of the complexing agents, which will alter the affinity of these two molecules, caffeine and benzocaine. Then the other factors to be considered while hydrolysis, it includes the surfactants. Now the surfactants are of various types. For example, the non-ionic surfactants such as SLS, okay. Then we have cationic surfactants, anionic surfactants. Now these surfactants are used to stabilize the drugs against the base catalysis. Now, for example, the 5% SLS shows 18-fold increase in the T half, that is the biological half-life of benzocaine. So when you are going to use 5% SLS, there is an 18% increase in the T half of benzocaine. Modification, so benzocaine modification of the chemical structure as well as ester. So what happens, this will modify, when you are going to use the surfactant, it will modify the basic structure of the benzocaine, and which will lead to increase in the T half of the benzocaine. So benzocaine is a local anesthesia. So this is how we have to study each and every aspect, whether there is an chemical degradation of the product. So how the chemical degradation of the product will happen, either it will be due to a hydrolysis, oxidation or reduction, or by racemisation, that we are going to see. So first point, under the hydrolysis, when we talk about, we have to consider, firstly we have seen the example under hydrolysis, we have seen the example of ester hydrolysis. So the factors which have to be considered in hydrolysis, we have to study it in a very minute way, so that we will come to know that whether we are going to prepare a stable product or not. So these are the things which we have to study, that is, for example, pH, type of solvent, then the complexation, then the surfactants. Now moving further, the second point under hydrolysis which we are going to discuss is amide hydrolysis. Now the hydrolytic reactions which results in amide plus, which results in amide. So when we have acid plus amide, for example, for certain drugs such as chloramphenicol and niacinamides, you will find it leads to amide hydrolysis. Now the ring alteration which takes place due to amide hydrolysis, it is due to the result of ring cleavage, and this is shown with the help of mainly in the drugs such as pilocarpine. Now pilocarpine is a drug which is used for the treatment of glaucoma. Then chloramphenicol is an antibiotic, okay, and this is niacinamides. These are the class of we can say vitamin B, that is subclass of vitamin B's. So we should be in a position to study this. So when you have studied the some of the practicals were there for physical pharmacy for you people, due to COVID I think so you may have not done, that is how to see the degradation pathway, that is how to study, how we study the degradation pathway of the drug, that is chemical kinetics. So there are some practicals in under physical pharmacy for you people to study how the degradation of a product takes place under acidic as well as basic media. So that is the main reason why we go and study out this thing. Now the second type of chemical reactions which we are going to discuss today, it includes the oxidation and reduction. Now before we move further, the combination of oxidation and reduction reactions, what they are called as, who's going to tell me? काय बोलतो आपण त्याला? हेलो, अरे I am asking you something, students. हॅलो. अरे मी तुम्हाला काहीतरी विचारतोय मुलींनो. तुम्ही आहे का क्लासमध्ये आहे सगळेजण? The combination
Sir,
of
redox.
what they are
Redox
called.
reaction.
Very good.
Redox reaction.
What they are called as? They are called as redox.
Redox reaction.
Fine. Now this redox reaction we are studying from 10th. Fine. Now as in hydrolysis, what was involved? It was the presence of water. Agreed? Hydrolysis मध्ये काय होतं? There was presence of water, okay, which will lead to the breakdown of the product. Here in oxidation and reduction, what is there? Here in oxidation, let's talk about first oxidation. We have a presence of oxygen, okay. This oxidation and reduction are the second most common way of chemical degradation of a product or the drug molecule, you can say. Now this oxidation and reduction are initiated by a catalyst such as we have light, heat, light, or the traces of metal ions. That will lead to production of free organic, that is, it will lead to organic free radicals. Now this production of free radicals, so this is called as a free radical production. So if you want to overcome this oxidation, what we are going to do? You are going to inhibit the production of free radical. So that's the reason many a times you may have heard one word in the various ads also. Mainly that is called as antioxidants. So the agents which are used to reduce or to combat this oxidation process, they are called as anti. Anti means against oxidation. Okay. So if I know while doing the pre-formulation studies, if my drug is more prone to oxidation, then what I have to do? I have to use such an agent which will keep my product stable. Agreed with this, everyone? हॅलो.
Yes, sir.
आता ही अशी गंमत आहे की वो प्रत्येक वेळेस तुम्हाला 2 मिनटं अरे जागे आहे का तुम्ही जागे आहे का ते सारथी असतो ना संध्याकाळी. ओके. जागते रहो ह्या पद्धतीने गंमत झाली. Okay, so up to this point it is clear. Okay, so the second most common way by which the drug get degraded is oxidation and reduction. So in oxidation we know that there is a presence of oxygen which can lead to the degradation of the product, and this oxidation process is inhibited with the help of certain type of catalyst, we can say, or the process of oxidation is increased by the presence of heat, light, and the traces of some metal ions, okay, which will lead to a production of radicals, that is free radicals, organic free radicals will be produced. And if my drug is more prone to oxidation, then what I'm going to do, if I want to make my product stable, okay, if my drug is more prone to oxidation and if I want to make my dosage form more stable, so what I'm going to add into that, I'm going to add antioxidant, so that my product is not going to get oxidized and it will be stable. Now these radicals which are formed, they lead to propagation. So they propagate the oxidation reaction which produce until the inhibitor destroy the radical or until side reaction eventually break the radicals in the chain. For example, dopamine. So there are various types of antioxidants. For example, you can take a simple example of alpha tocopherol, or you can take an example of we can say ascorbic acid, that is vitamin C. So what normally many of the antioxidants, they undergo self oxidation and they keep the product safe from oxidation. Okay, so moving further with our discussion, now first try to understand when a substance get oxidized. Firstly, when a electron, when the electrons are removed from it. So suppose if you have a substance, that is a drug is there, and from that you are going to remove the electrons, okay, then it will lead to oxidation. Then gains electronegative atom or radicals, or loss of electropositive atoms or radicals, it will also lead to the oxidation process. Then addition of oxygen and the removal of hydrogen, what it is called as हे तुम्ही शिकताय ना रे प्रत्येक वेळेस.
Oxidation and reduction.
ओके, ॲडिशन ऑफ ऑक्सिजन म्हणजे
Oxidation.
अँड रिमूव्हल ऑफ हायड्रोजन म्हणजे
Reduction.
ओके.
Oxidation.
ओके, काय मला सांगा, कोणी ऑक्सिडेशन म्हणतं, कोणी रिडक्शन म्हणतं. आर दे वन अँड द सेम ऑर दे आर डिफरंट?
Different.
They are different. Fine. Now, the most common form of the oxidation is auto-oxidation. That is free radical chain process. As I told you, the example of vitamin C as well as alpha tocopherol, but if they are going to be used under in a certain dosage form or in a formulation as a antioxidant, they undergo first oxidation, that is self oxidation they go, that is called as auto oxidation, so which is free radical chain process. Now it involves homolytic bond fusion of a covalent bond, and each atom retains one of the electron of the original covalent bond. So when we talk about this process of auto oxidation, which is also called as free radical chain process, it involves the homolytic bond fusion of a covalent bond, now in which each atom will retain one of the electron of the original covalent bond. Now with the help of this reactions which are shown in the next slide, you will be, this concept will be more clear to you. So I hope everyone can see this reactions which are shown over here. So in oxidation process, mainly in the under oxidation process for auto oxidation, the process goes in such a way, that is firstly there will be initiation. So can anyone tell me what do you mean by R and what do you mean by H?
R means alkyl group.
Okay, H means hydrogen.
Hydrogen.
Okay. पोरींनो, ती पोरगी म्हणली आणि मी म्हणलो म्हणून ठीक आहे असं नाही, तुम्ही पण समजून घ्या. This R will be your alkyl group, H is your hydrogen. So in first step what will happen, there will be RH initiation. So RH, so as we have seen, the triggers will be either it will be by light or heat, okay. There will be activation or it will lead to auto oxidation, and you are going to get R separate as well as, that is the alkyl group separate as well as hydrogen separate after activation. Then the second step will be propagation, where your alkyl group plus oxygen will lead to RO2. Okay, so RO2 plus your the product which you got in the first step, that is initiation, which will lead to ROOH. म्हणजे काय? ROH म्हणजे काय? Can anyone tell me? हे काय आहे? ऍसिड काय आहे? Mulinno, I am asking you something. What it is? ROOH,
Carboxylic acid.
carboxylic acid. Okay, म्हणजे इथं काय झालं फॉर्म? It has lead to formation of acid. Okay, in the second step, that is propagation. Okay, then in the third step, what happens is this carboxylic acid which is formed in the third step of hydroperoxide decomposition. So whatever there will be the decomposition of hydroperoxide taking place over here, where your carboxylic acid will break down into RO plus OH, that is hydroxy. Okay. Then next, that is the fourth step, will be termination, where we have RO2 plus X will lead to an inactive product, that is the X convert to the peroxide groups. So what has happened? Your drug has got converted into the peroxide groups. Okay, it means from here, even though the actual process of auto oxidation has started from the initiation point, but the final products which you are going to get after auto oxidation will be the peroxide groups which will be attached to your drug, and it means there has been some chemical degradation taking place into your drug molecule, and then we are going to get an inactive product. So, and the rate of we can understand this more easily with the help of an example, that is the rate of prednisolone, which is an steroidal drug. If this prednisolone drug is in stored in presence of an aerobic and anaerobic conditions, it can lead to auto oxidation. Then we have, if you are not keeping the lid of the container where you are going to keep your certain types of compound, for example oils and fats, it will lead to rancidity. Many a times if you keep the oil open in your kitchen, you will find it gets a typical smell, that is it gets a rancid smell. So this is how you can avoid the auto oxidation. Then we have, if you that means to avoid the auto oxidation, we have to close the lid of the container in a proper way. Then oxygen contained and the antioxidants. Now let me explain with the help of one of the example, that is what is the very important role of molecular oxygen. Means whatever this oxygen, that is O2, which will lead to the oxidation process. Normally, if my drug, if I have a API or drug which is more prone to oxidation, okay. Now, for example, if I am preparing a parental dosage form, मला हे delete करू द्या. If I am going for parental dosage form and I am going to later on put this into an vial, okay, into a vial or ampoule. For example, we'll take an example of vial, okay. My drug or API is more prone to oxidation, okay, whatever the API I am going to have over here, and up to this capacity, if this is an 5 ml vial, what I am going to do, I am going to prepare it in a solution form, बराबर है. पण समजा this space, let me change the color. If I have, we'll take purple color, okay. So in this space, we are going to have oxygen present, means all the air present. Do you agree with this?
Yes, sir.
And if my drug is already prone to oxidation, so what I can do to avoid the degradation of my product or to make my product more stable, this molecular oxygen, that is O2, is replaced by nitrogen. कशाने replace करतो आपण? Nitrogen. So this is how we can make the product stable. So that is the reason why we have to see that how the drug will get degraded, means whether it is stable or not. So for that we have to do this. We have to study the chemical properties also in detail. Agreed, everyone? Okay.
Yes, sir.
आता now let me take another example for you people. Okay. Container सगळ्यांना माहिती आहे का? Containers. हॅलो, कंटेनर सगळ्यांना माहिती आहे का? मला
Yes.
दोन दोन
Yes,
टाईप
sir.
दोन टाईपचे कंटेनर असतो. एक असतो ब्राऊन कलरचा, ओके, लेट मी टॉक इन युअर लँग्वेज ओनली, आणि दुसरा आहे तो व्हाईट कलरचा. ओके, ॲक्च्युली कलरलेस किंवा व्हाईट नाही म्हणत त्याला आपण, इंडस्ट्रीमध्ये इट इज कॉल्ड ॲज फ्लिंट. जो व्हाईट असतो त्याला आपण काय म्हणतो, इट इज कॉल्ड ॲज फ्लिंट. दिसतंय का मी लिहिलेला शब्द याच्यावर?
Yes, sir.
ओके. देन वी हॅव समथिंग कॉल्ड ॲज अंबर कलर. PR, मला ह्याच्या लिहिता येत नाही, थांबा, मी याच्यावरच लिहितो कॅपिटलमध्ये. अंबर कलर, ओके. नाव दिस अंबर कलर इट हॅज अ ट्रेसेस ऑफ एलिमेंट्स. काय असतो त्याला कलर जो येतो ब्राऊन कलर, इट इज ड्यू टू द प्रेझन्स ऑफ आयन. कशामुळे येतो? आयन. आणि आपण ऑलरेडी काय पाहिलेलं आहे, ॲक्टिवेशन काय असतं की तुमचे मेटल आयन्स त्याला ॲक्टिवेट करू शकता. सो वाईल सिलेक्टिंग द कंटेनर फॉर युअर ड्रग प्रोडक्ट यू हॅव टू बी व्हेरी केअरफुल. ओके, सो मेनी अ टाइम्स यू कॅन कम टू नो. आता आपण काय करतो की आंबर कलर कधी यूज करतो की ज्यावेळेस तुम्हाला माहिती आहे की तो लाईटने अफेक्ट होणार आहे, बरोबर आहे. सो जे काही तुमचे हार्मफुल रेडिएशन्स येणार आहे ते त्याला तिथंच थांबवणार आहे, म्हणजे त्याची इंटेन्सिटी कमी करणार आहे. सो दिस इज हाऊ द होल थिंग गोज ऑन. हा पॉईंट समजलाय का मला काय सांगायचं होतं तुम्हाला मुलींनो?
Yes, sir.
हां,
Yes,
एक
sir.
लक्षात राहू द्या, काय अंबर कलरमध्ये टाकायच्या वेळेस त्याला यू शुड हॅव अ व्हॅलिड रिझन. नाव सपोज इफ यू वॉन्ट टू प्रोटेक्ट इट फ्रॉम द सनलाइट देन इट इज अंबर कलर, इट्स फाईन. बट you have to also take a precaution that if your drug is undergoing oxidation in presence of metal ions, so that time you can't use amber color, so you have to move towards a flint or colorless container. Getting the point? Okay, now let's move further. uh, okay, now the next reaction is photolysis. Now this photolysis, it takes place with the help of photochemicals or the agents which are going to lead to the photosensitization. So these are the things which will be the triggers for the photolysis. For example, photochemicals, then photosensitizers. When we can overcome this, that is the UV violet portion, which is the most active portion from the whole region of the light, okay, which is having the shortest wavelength and having the more energy, and that's the reason we say that UV rays, they are more harmful. So many a times in summers we see that we use sunscreen lotion which will protect you from the harmful radiation of UV. In the same way, our drugs are not no exceptions for this. So we have to keep your drug protected from the harmful radiations also, that is UV radiation. So when we'll come to know that whether it is going for degradation, only after we study the chemical properties. Okay, so this was regarding photolysis. Now moving further, the last point which we are going to discuss in today's discussion is regarding the racemization. So under racemization, firstly we'll understand what do you mean by racemization. Now racemization is a process in which we have one enantiomer of a compound. Now I am not going to go into the basic details of this chemistry part. केमिस्ट्री तुम्ही ऑलरेडी शिकलेले, तुम्हाला माहीत आहे की ज्यावेळेस तुम्ही स्टेरिओकेमिस्ट्री शिकताना तुम्हाला शिकवलेलं आहे की इनॅन्शोमर म्हणजे काय. ठीक आहे, शिकलाय ना तुम्ही सगळ्यांना आयसोमर म्हणजे काय, शिकलाय का नाही?
Yes, sir.
Yes, sir.
So is the process in which one isomer of a compound such as L-amino acid convert to another enantiomer. Now just if I want you people to explain in the simple language, means racemization is a process in which one enantiomer is converted to another. बराबर आहे. So एक enantiomer दुसऱ्या enantiomer मध्ये कन्वर्ट होणार आहे. ओके, दॅट इज कॉल्ड ॲज racemization. And here we have seen an example of L-amino acid which gets converted to another other enantiomer. The compound then alternates between each form with the ratio between the plus and minus groups. While the ratio between the positive and the negative groups approaches 1:1, at which point it becomes optically inactive. ठीक आहे, ऑप्टिकली इनॅक्टिव्ह. आता तुम्हाला माहिती आहे, जे प्लेन पोलराइज लाईटला समजा पॉझिटिव्हली फिरवलं त्यांनी क्लॉकवाईज, तर त्याला आपण काय म्हणणार आहे, इट इज कॉल्ड ॲज डेक्स्ट्रो रोटेटिव्ह. इफ इट इज अँटी क्लॉकवाईज, इट इज कॉल्ड ॲज लिवो
Levorotatory.
Okay, so that is what we have to know for a particular compound. Now, if the racemization results in a mixture where the enantiomer are present in equal quantity, the resulting samples is described as the racemic mixture or the racemate. Fine. So let's see some of the examples for the racemate or the racemic mixtures. So you will have more clarity. Now the interconversion from one isomer to another can lead to lot of differences in the pharmacokinetic properties of the drug molecule, such as ADME, that is absorption, distribution, metabolism, and excretion, as well as the pharmacological and the toxicological effect can also vary a lot. Now let's see with the help of an example, that is when we talk about L-epinephrine, that is the levorotatory epinephrine form enantiomer, it is 15 to 20 times more active as compared to the dextro form of epinephrine. While activity of racemic mixture is just 1/2 of the levo form, that is the levo form. Now from this, what you can understand, directly if you are using a racemate where you have a combination of levo as well as dextro epinephrine, it is just having a half of the activity as compared to that of the L-epinephrine, which is having 15 to 20 times more activity. So that's the reason we should know which enantiomeric form is active, which will give us a more therapeutic effect, and also the desired, not only the desired therapeutic effect, but also it should be safe as well as stable. Now this whole properties of an racemate, it depends mainly on the temperature, solvent, then the catalyst if they are present, and the presence or absence of the light. Now let's try to understand what's the biological significance of when we study the racemization. Mainly, many of the psychotic drugs, they shows different activity or efficacy between the isomers. For example, when we talk about amphetamine, which is often dispensed as a racemic salt, while the more active dextroamphetamine is reserved for the severe indications. So this is what we should know. See, in the first example of epinephrine, we have seen आपण समजा रॅसेमेट डायरेक्टली किंवा रॅसिमेट किंवा रॅसेमिक मिक्सचर वापरलं तर इट इज ओनली हॅव्हिंग 1/2 of the activity as that of the L-epinephrine, which is the more active form. Then for the second drug, that is the second example of a drug, that is amphetamine, which is an psychotropic drug. Okay, it is often dispensed whenever it is given as a racemic salt. Okay, but we use the more active active form of the amphetamine, that is the dextroamphetamine, only for the severe conditions. And the another example is of methadone, which is having the isomers also, of which one isomers is having a activity as an opioid opioid antagonist and the other as an NMDA antagonist. So this is, as we have a different isomer for a particular drug, different isomers can have, they have the different ADME properties, and it can give us the different pharmacological and toxicological effect. Okay, so with this we have discussed all the points from the chemical properties under pre-formulation. Now the remaining things we'll be discussing in the